Welcome back, episode 3 of ReliaCast. Can't believe it. We have been quite a while now producing this video, but we've got there in the end. I was really lucky to be invited out to ESREL 2023, and we discussed data mining. So I put together some material from our interview. It's a face-to-face interview, so it's different to what we've produced in the past. I hope you enjoy.
Welcome to ESREL 23, everybody!
Hi guys, Chris Wynn-Jones as promised. I have here Morco Bonato, who is here to discuss the topic of data mining. So I'll start off with letting Morco introduce himself.
Yeah, thank you, Chris. Thank you for the invitation. I work as reliability manager for Valeo Thermal Systems, a French-based company, automotive component manufacturer, and thermal system because we deal with all the components that are responsible for the thermal management of the car, cabin, engine, the battery, and I'm leading the reliability of the components we systems also we produce nowadays.
Awesome. That's great. So, as I say, we're here at ESREL 2023. So, I've been invited down by Morco to help out here. We're joint chair.
We co-chair
for our section. And very interesting. I think that was. And I heard the presentation that Morco had in mind about data mining. So, let's start off with the first question. What is data mining?
Data mining is the what makes you search into your data and try to leverage all these informations and get specific knowledge that can help you in answering your questions. So in our case with data mining, try to ask a specific question. So in Valeo, I'm also expert of predictive reliability. So most of our data mining is, can we analyze our database, or maybe we can talk later what kind of database we had, and extrapolate information that can facilitate the reliability predictions of our components, make it faster, efficient, robust, and more precise.
Right.
So a lot of advantages in doing that. I use the word leverage. It used to be a buzzword some years ago.
Right.
Reliability started with, we should do big data. Everyone talking about big data, no one doing big data. Then it went into big data, mostly of time series, fleet of cars, whatever, didn't work that well. Then we moved into leveraging, okay, just a buzzword. And then specifically in Valeo, we realized that we had the powerful of having all these databases, more or less structured, where you could extrapolate information. So data mining combining with machine learning techniques allows you to perform some nice statistical also investigations of.
So with the data mining, you going on the mentality of big data from some people from our side of the engineering world, very familiar with big data, and so basically taking that big data and the data mining is you effectively grouping up similar data and data that associated with another piece of data. You're seeing that recognition of the association, and once you've got that, we're thinking more down the sort of identifying failure modes from the data, failure modes that we might have missed. So we've gone through the design phase, the product's out there, it's running, and we're getting information back from that product while it's out in service. But that information is just a whole, if you listen to all of it, it's just all noise. So my understanding with data mining from yourself is, so you're using the data mining techniques to filter that data to identify failure modes that we might not have thought about.
Yeah,
when you designed it.
that was one of the part of.
Yeah.
So one of the big database we have concerns warranty returns. So there are number, dates. The failure mode is not descripted. There's more the verbatim of the car owners or the repair shop, whatever it's called.
Okay.
So our idea was to dig into these phrases, sentences, words, and do some analytics, machine learning based analytics. Create a model, train some data with the help of an expert. So you have an input data and you can predict some failure modes, and then be able to go through all these. It's a well-structured database, and try to, why not, possibly associate to each failure claim a failure mode.
Yeah.
So, and why big data? Because we have a lot of data we can collect for our customers, and the idea is also to try to use generative AI, so you can also predict failure modes from this.
Okay.
This database, it's
So if you've
warranty claims.
If you've got a failure mode that you already recognise, then the AI can recognise that failure mode and then give you statistics automatically.
Yes.
I see. I'm with you.
And then the idea of having all these models that you also use to at FMEA level,
Yeah.
to try to predict failure modes, which in my opinion gets very interesting when you move from components to systems, which was also one of the presentations from Felicia and Campiano.
Yeah. Right. Thanks for that.
Analysis. So the second example I introduced today was related to a database of tested components. We do a lot of validation tests, design validation, product validations, etc., audit validations. And what interesting to see, it's okay, can I get some statistics? What's percentage of test I'm doing, split it into components? Maybe you can use it later, I don't know, marketing or some kind of stuff. And the idea, the example we gave today is that if you do manually, it's going to take a lot of time. We are interested in the name of the product, okay, a radiator, a fan system. If you do manually, it's going to take a long time, because we have a lot of different types of test reports and different language. We're a worldwide company, and very often the name of the product is not specifically mentioned. There might be acronyms, there might be identification numbers from Valeo or from the customer that the guy that is reading the report, the project managers know, but the guy tried to extrapolate the data. Okay, it says unknown. But if you apply an automatic process of natural language processing coupled with, again, machine learning, is able to learn, assign some specific characteristic of the test report of the product under testing, and also fill this gap with this all unknown. So I made the example today. We went from a high percentage of unknowns to a very small percentage, and in a rapid way. So this is to some extent big data, because you have a big amount of data and you're creating this model that allows to extrapolate data.
And with the techniques, you're going into that data pool.
Exactly.
And then
what I really like of our session is that we are in a very nice academic conference. The people brings a model. Okay, I have a new model for bearings degradation. Bearing degradation's prognosis started 30 years ago, but still they are proposing new models. What we are trying to do is, engineers, we have a problem, we want to propose a solution, and we start applying this.
Yeah.
There's trade-off between accuracy, time, efficiency, whatever, but it's something we want to use. This is the way we.
Yeah.
It's not purely. It's applied research.
Yeah, it's been really good. It's been a pleasure talking with you. Just briefly cover that topic.
Okay.
Thank you for your time.
Okay, thank you,
It's been a
Chris.
pleasure. Thank you very much. And